Okay, welcome back guys. We're going to be solving another question from the third chapter of the Meriam textbook, question 7. And we have this 275 kilogram drum that is being hoisted by the lifting device which hooks over the end lips of the drum. We need to determine the tension T in each of the equal length rods which form the two U-shaped members of the device. So before we start, we are in equilibrium. We know we can use our sum of all forces equals 0 equation, and same for the moment and by F, since we can treat this question as a 2D question. If we have an observer here looking at this, what we see pretty much will be a 2D assembly, which we have the point C in here, and we have one force on that side, and we have two forces from the rods, and that's pretty much it. And if I look at this system as one single system, so that was pretty much for the hook C, but like if you want to look at the whole system from the point of view of this observer, we see this drum that is connected with these two rods, and we have the lifting device on top. So if we look at the whole assembly as one single thing, we obviously have the weight of the drum, which is 275 kilogram times acceleration of gravity 9.81 meter per square seconds, and let's call the top part, we can call this one F. And if we do our Fy equation, calling this one positive, so for y we can call our x and y in here, so yx, this will be with positive sign for x and y. So basically we have F minus W is equal to 0, which means our F is pretty much the W. But what we're interested in here is if we look at the end part of the equation, we need to find the tension in each of the equal length rods. So we can call this one T, and since there is 2, we're gonna call 2T, because we have to find the tension in each rod. That's why we put 2 in here and here, in order to find the T, which will be the tension in each rod. And as we figured, this force in here is the weight from the free body diagram. So we started with the free body diagram of entire system in order to find the force F in here, which is what we found in here, is equal to W. And now we're gonna proceed with the free body diagram of the junction C. This part is pretty easy. As long as we have the angles here, we can do just the sum of all forces in y direction and find this T easily. But let's figure out the angle that we have in here. So we can call this angle theta, which is the angle that we are talking about, is this angle theta. So if we look at this right triangle here, it should be easy to find the theta, because we know this side is what we have in the figure 250 millimeter, and if we want to find this side, all we need to do in here is just to divide 900 by 2, because we have this whole 900, which means this will be 450, and same for here, 450 here too. So this side is 452, so this side will be 450 millimeter. And if we want to find theta, we simply have the tangent inverse of opposite, which is 250, over adjacent, which was 450. So our theta will be 29.05 degrees. And now easy enough to do our sum of all forces in y direction, which will be W minus 2T. We can see that the y component will be sine of theta, or sine of 29.05 degrees, and we have the same thing on the other side, sine of 29.05, or we could have written minus 4t times sine of 29.05. But we're just trying to show the whole system in here, and W is known, basically our W is 275 times 9.81, which will be 2697.8 Newton. And if we just plug in our W in the previous equation, we can find T, which will be 1389 Newton, which will be the tension in each rod. So not very complicated question. The figure is shown in 3D, but this is actually a 2D question, and you could have seen at the beginning that the force in this cable or at the top part is W, but like if you want to see where this is coming from, it's coming from the free body diagram of the entire system, which our F will be equal to the weight, and from here we can find the tension in the cable, which would be the final answer for this question. Hope you guys find this one helpful. Please make sure to subscribe to the channel, like and comment. It's going to help me to reach out to more students, and feel free to drop your questions in the comment section. I'd be happy to answer those, and you guys take care. I'll see you in the next video. Have a good one.